Okay, this is just a quick video to give you a graphical overview of the sort of data that you get from an isokinetic output. First and foremost, we have the graph itself. So up the y-axis, we typically have torque, which is measured in Newton meters, and on the x-axis we have time. Therefore, this is a a torque time graph. The area underneath the curve is angular impulse. So remember, with a kinetic force plate measurement, which is a force time graph, we have impulse under the curve and rate of force development is the line. In this case, we have the angular equivalent of that. Torque, Newton meters, time, angular impulse underneath the curve, and rate of torque development is the curve. So typically you'll see a graph that looks something like this, with no distinguishing features between the peaks other than what you know that you've tested. So when you're testing agonist and antagonist muscle groups, you have the larger muscle group, in this case quadriceps hamstrings. The quadriceps should be the strongest muscle group, so you should see, here we've done 2 repetitions. So our first repetition is here. This would be rep 1, so knee extension, knee flexion, and repetition 2, knee extension, knee flexion. You start the test with the knee at 90 degrees of flexion and extend. You begin with knee extension, so even if the first peak is smaller, you know that that represents the knee extensors. So the repetitions we have here, so this is, as I say, extension, this is flexion. One of the most important measurements that we can get from isokinetics is peak torque. So peak torque for each flexion and extension repetition basically takes the highest value. So in this case, the peak torque of the quadriceps would be this value here, and the peak torque of the hamstrings would be whatever this value is here. Now, this is a widely reported measurement, and it is useful because it's used in a lot of other measurements that are used on a isokinetic report. However, the more repetitions that are performed, the less useful this measurement is. Remember that any maximum or minimum value, like peak torque, is by definition an outlier. It is the maximum value. It is not representative of the set as a whole. So it's also worth comparing peak torque, which is the first measurement that you'll see at the top of an isokinetic report after the number of repetitions and the test information. It is worth comparing this with average peak torque to see if the deficit is the same. If there's a large deficit in peak torque that isn't present in average peak torque, it is perhaps best to assume that that deficit that's present with peak torque isn't truly representative of that athlete or that participant's performance, because it is perhaps just an outlier. Maybe they just tried a bit harder on that repetition, maybe you didn't tighten the straps up properly. So check peak torque, see if there's a deficit. Let's say you've got a deficit of 15%, then look at average peak torque and see if that deficit is still present, particularly when you're working at higher angular velocities and you're performing more repetitions.